In this question, we have to determine the equation of a line that is perpendicular to this line and has the same y-intercept as this line. And one way to express the equation of a line is in the form y equals mx plus b, where m is the slope and b is the y-intercept. So if we can find the slope and the y-intercept, then we can find the equation of the line. Well, let's see what they give us in the question. The first point is that our line is perpendicular to this line here. As soon as you see the word perpendicular or the word parallel, you know it has something to do with comparison of the slopes of the lines. So let's take this line and figure out its slope. So we'll bring down 3x minus y equals 5. And if I want to isolate the y so that I can put it in the form y equals mx plus b to find the slope, what I need to do here is rearrange the equation. So instead of a minus y here, I'm going to add a y to get rid of it because we need a positive y. So I have to do the same on the other side. And here we can see these cancel, and that leaves me with 3x equals 5 plus y. And if I want to isolate the y, then I have to subtract 5 from both sides. So I get 3x minus 5 equals 5 minus 5 plus y, and the 5's cancel, leaving us with 3x minus 5 equals y. Now we could also write that as y equals 3x minus 5. It will be exactly the same equation, and that's in the form that looks similar to what we have over here. And that will tell us that our slope for this particular line is 3. But what we want is the slope of a line perpendicular to this line, or this line here. So how are perpendicular lines, how are their slopes related? Well, our line, our slope here is equal to 3. Now we can also write that as 3 over 1, which would mean the same thing. And then a line perpendicular to it, m perpendicular, happens to be the negative reciprocal of this slope, which means you swap these two values and change the sign. So the slope of the perpendicular line would be negative 1/3. And if you're not sure about that, what you could do is start with a point here and look at our slope of our line right here. And this means, the rise is 3 and the run is 1. So from this point I go up 3 and over 1. Put another point there, and then draw a line through those points. And again, the rise is 1, 2, 3, and the run is 1. Now let's draw a line perpendicular to that. Let's say we go through this point perpendicular, which means it's at 90 degrees. And when we do that, we can see that actually you go down 1 and over 1, 2, 3 to get to your line. So it's down 1 and over 3. So we see that the rise became the run, and the run here became the rise here, but in opposite directions. We notice that the slope of this line is positive, but the slope of this line is going down, so it's negative. Okay, so we have the slope of our line, but what we need now is the y-intercept, and we're told that the y-intercept is the same as represented by this line. So let's rearrange this line in the form y equals mx plus b, and then we can find b for our y-intercept. So we'll bring it down. 4x minus 3y minus 12 equals 0. And what I'm going to do is I'm going to isolate the 3y. So I'm going to get rid of it from the left side and put it on the right side of the equation. To do that, I would need to add 3y to both sides. So minus 3y plus 3y to get rid of it, minus 12 equals 0 plus 3y. These cancel, leaving us with 4x minus 12 equals 3y. And we want to get y by itself, so we divide everything by 3. And we'd end up here with 4/3 x minus 4 equals y. These would cancel. 3 goes in there once, goes in there 4 times. like before, we could also write this as y equals 4/3 x minus 4. And that looks just like this equation we have, and so therefore the y-intercept would be the constant at the end, which would be -4. So for our equation, b is going to be -4. So the equation of the new line would be y equals -1/3 x minus 4, where our slope is -1/3 and our y-intercept is 4. And there you go. I do want to point out another way we could have found the y-intercept for this particular line. If we think of a graph, a y-axis, x-axis graph, if we cross the y-axis, let's say a line here, we'll notice that the value of x at the point where the line crosses the y-axis is 0. So for any y-intercept, the x value is 0. So what we could have done is bring down 4x minus 3y minus 12 equals 0 and substituted 0 in for x and solved for y. And if we did that, we get 4 times 0 minus 3y minus 12 equals 0. That would be minus 3y minus 12 equals 0. I'm going to isolate the y, so I'll add 3y to this side. Plus 3y minus 12 equals 0 plus 3y. I have to add 3y to the other side as well. Those cancel. Minus 12 equals 3y. Then we can divide both sides by 3, and we end up with y equals -4. So that means our y-intercept is -4, or the point 0, -4. So if I was to go back up and draw the graph with that point as the y-intercept, we would get the following. For our line, 0, -4 is down here, and we know the slope is -1/3, so it's a shallow slope going something like that. So again, our new line equation would be y equals -1/3 x, because slope is -1/3, with a y-intercept -4, so y equals -1/3 x minus 4. Just another way to do it.